In this video, I am going to draw and calculate an 8-bus power system using DIgSILENT PowerFactory software. In the previous video, we worked on exercise of DIgSILENT that mostly all the types were defined by DIgSILENT. But in this video, I will model a new network system in DIgSILENT, so we should create the types manually. This is the image of IEEE 8-bus network system that I am going to implement it in the DIgSILENT PowerFactory. And this is the data that I provided in the Excel. As you see, these are the data for line characteristics. These are the generator data, and these are load, and these are also the transformer data. For creating a new network system, firstly we should create a new project. From File, in New, select Project. Name your project, and I am going to name it as IEEE 8-bus. Then click OK, and a new dialog appears as grid. You can change the name, but I don't want to change it. From here, you can change the color and the nominal frequency, and I am going to write the owner name here as also Pro. The owner field is optional. Then click OK. As you see, the newly created project and study case are activated automatically. This is the empty single line graphic window with drawing grid that we are going to draw our system. There are two ways to draw the system. One way is you just look at the image, then draw the system, and it may take your time. There is an easy way, that is installing the image of our network system as background. Let us learn how to do it. From the graphic layer, click on Configuration, then from the layer, select Background. Select your background file by clicking here. I saved the background image on my desktop, so click on Desktop. This is the background image, select, and then click on Open. Click OK. We still can't see the background because it is in the invisible list. Let us put it in the visible list. Now the background is installed. It is nothing, just a pattern to show where to place the actual power system components easily. Let us draw our system. Starting from substation, select a single bus power system icon from the toolbox, then place it to all substations according to the number respectively. Then draw lines between each of these bus bars. Click on line icon in the drawing toolbox, then connect the bus bars according to the name respectively. I am not going to explain them because we knew them from the previous videos. There are also two transformers between this and these bus bars. Click on two winding transformer icon, then place it to the position suggested by the background pattern. Now our bus bar are connected, then connect load to bus bars shown by the background. The last elements which are needed to draw are creating single port elements. We have two generators and one external grids, so place them to the position shown by the background. The creation and the topology of IEEE 8-bus power system is completed. By using move or resize, check that all symbols are positioned correctly. These elements have not been edited yet. Creating the types and entering the parameters are the next steps. The background is not needed anymore. To hide it, click on the show layer icon. As you see, the background layer is shown in the left pane visible list. Click here to move it to the list of invisible layers. Then click OK. The next step that I am going to show you is how to edit the power system components. The DIgSILENT program offers different methods for editing the electrical parameters of power system elements. One simple method is double-clicking on the elements in the single line graphic. If you have a bigger system, double-clicking on each of the elements may take a lot of your time. To avoid wasting time, click on the Edit Relevant Object in the main icon bar. This is one of the methods that allow us to edit the power system components faster. If you click on all icons, you will see all the power system components used in the system. But I want to see all the bus bars or all the cables or transformers separately. Actually, the DIgSILENT software provides the option for us. For example, if you click on substation, you will see only the bus bars, and if you click on the synchronous machines, you will see only the synchronous machines that are used in the system. Now let us use this method to name our bus bar. Click on substation and a new editing dialog is appearing. Enter the name for each of them. Let us write bus bar 01. If you click enter, a star symbol is created next to that. Again click enter to save it. Coming to the next line, write bus bar 02. Then double enter. If you have a lot of elements, there is a faster way to enter the name. Let us do that. Go to the Excel and type the name of your bus bars. Then copy all of them and paste them here. And close it. Now you see that all the bus bars name is changed. If they are not changed, click on the rebuild icon. As you see, the name of our terminal says BB for all the substation. Let's change the name of our terminals and apply the same steps as we did in the bus bars. Now you see that the name of terminals are changed. Let's apply the same steps and methods for lines, loads, transformers, and generators. So far we create the power system components and enter the name for them. The next step that I am going to do that is creating type and entering the parameter for our system. Let us start from the cable. For every this cable we need to define a particular type. Double click the first line, the edit dialog appears as you see. From the type, select new project type, then click on line type. Name it as line type 01. Then enter rated voltage. If we look at the data, the rated voltage for all lines are 150 kV. So enter 150 kV for the rated voltage. Rated current is 1 kA as it is, and nominal frequency is 50 Hz. Type of cable or overhead line should be overhead line. System type is AC 3-phase system, and the number of neutral is also 0. For the resistance and reactance, let's look at the data. Resistance is 0.004 and reactance is 0.05. Enter the value for each of them. If the parameters for zero sequence is not defined, assume a value as 3 times of the parameters of positive sequence, if that is not an underlying cable. If we multiply 0.004 by 3, it will be 0.012, and this one will be 0.15 ohm or kilometer. Then click OK. Now you can see the resulting values from here, such as positive sequence parameters, zero sequence parameters, and the earth factor. Number of parallel lines is 1 and the length of the line is 100 km. In the line model option, you can either select lumped parameters or distributed parameters. But for the short line, generally the lumped parameter is used and we don't need to change the other parameters. Click OK. Now the number 1 line has type. If we go to edit relevant and select line from here, you will see the type of the number 1 line. If you want to see the location of the line type, open the data manager, then click on the active project, click on the library. Inside of the library, our created line type is in the folder of equipment type library. Let's apply the same steps for the other lines. Now editing of the lines are completed. Let's jump to the editing of terminals and bus bars. Double click on the first bus bar. The edit dialog appears. Then click here, select new project type and name it as bus bar type 01. And nominal voltage is 150 kV. Then click OK. Change nominal voltage to 150 kV. No need to change the other parameters. Click OK. Do the same steps for the other bus bars. As you see, the bus bars 7 and 8, which are connected to transformer, have 10 kV nominal voltage. Enter 10 kV nominal voltage for them. Now edit the transformer. Double click here and new edit dialog appears. Then select new project type. From type, name two winding transformer type 01. This is three-phase transformer. If we look at the data, the rated power is 150 MVA. Nominal frequency is 50 Hz. In the data, high voltage is 150 kV and low voltage is 10 kV. So enter 150 kV in the high voltage side and 10 kV for the low voltage side. And change the zero sequence impedance to 4%. Then click OK. From the load flow, make sure that the tap position should be 0. And this should also be disabled. Then click OK. Do the same thing for the other transformers. Now it is time to edit the loads. Double click on the first load, then set its type, select project type, click on general load type and click OK. Click on load flow. If we look at the data, the real power and reactive power is provided. So we conclude that the loads are PQ. So select PQ. This should be in balance. The active power is 40 megawatt and reactive power is 20 MVAR. Then click OK. Let us do the same steps for the other loads. The final elements to edit them are single port elements, that is 2 generators and 1 external grids. To edit the external grid, double click and name it as transition grid. Then click on load flow, select from here slack bus. No need to bring any other change. Click OK. Double click here on the synchronous generators and set its type. Select new project type, name it as type 01. If you look at the data, the nominal apparent power is 150 MVA and nominal voltage is 10 kV. So enter the values. Assume power factor as 0.65. Then click OK. In load flow, we don't need to change any parameters and they are changed automatically. Click OK. Let's do the same thing for the other generators. Yes, now editing of the power system elements are finished and our system is ready to perform load flow calculation. Click on load flow icon, then click on execute. The red color that you see here show the overloading condition. In the next video, I will talk more about why overloading occurs and how to improve our network system. That is all for today. Thanks for watching. If you like the video, please subscribe our channel.